Section 1.6 is solving linear inequalities. I thought I'd start with the practice page because some of this visually is a little easier to look at. I think we're relatively familiar with inequalities. Notice that sometimes I have an open circle and sometimes I have a closed circle. In this case, my value could be equal to 2, but not equal to -1. So that would be number 2, right? My values are somewhere between -1 and up to and including 2, so less than or equal to 2. So anytime you see a closed circle that's includes equal to, anytime you see an open circle that does not. And notice the difference here. This is an in between. X is between -1 and 2, including 2. In this case, I have an or because x is less than -1 or x is greater than 2. There is no overlap there, and that's when you get an or. And that's going to become more significant in the next section. So if you were recording these on your page, it does say match. So suppose I had number 4 just said x is less than 0. So a sketch for me is fine. X is less than 0. So it's an open circle and my arrow goes to the left. Something relative is fine. The next section again asks that question, is this a solution of the inequality? So here is the inequality. The question is 2 a solution? Plug in and check. I want to know, is the solution means does this work? So 4 minus 3 times 2 is greater than -2. 4 minus 6 is greater than -2. And this is no, it's not greater than. If this was equal to, it would work. But in this case, no, this is not a solution. No, 2 is not a solution because this is not true. Solve the inequality. There's some that are relatively straightforward, like number 16 says 4x is greater than -16. Divide by 4, x is greater than -4. Sometimes you have to remember that when you divide by a negative, when you multiply or divide by a negative, then the symbol reverses. So in this case, if I want to undo -1/2, I multiply by -2 over 1. So my negatives cancel, the 2's cancel, and I have to change the sign. When you multiply or divide by a negative, you have to change the symbol. X is greater than 14. Then number 20. Were you guys able to see that? In number 20, I need to pay attention to my video monitor as well. Number 20, 6 is less than -3x, or -3x is between 9 and 6. -3x is greater than 6, but less than 9. You can solve these simultaneously. So whatever, it used to be whatever you did to one side, you do to the other. In this case, you have 3 portions, and each one you can perform the same operation on. So -2x, -3. X is between -3 and -2. How can it be? Oh, I divided by a negative. I was going to say that can't work. How can you be less than -3 but greater than -2? Well, because I divided by a negative, I have to change the sign. That makes a lot more sense. X is greater than -3 but less than -2. Then if we do an or, 4x is less than or equal to -12, or 4x is greater than or equal to negative 4. If I divide by 4, I get x is less than or equal to negative 3. If I divide by 4, I get x is greater than or equal to negative 1. And again, that's, I'm down here at negative 3, or I'm above negative 1. There is no overlap, so the or makes sense. In this case, I'm between negative 3 and negative 2. That makes sense. I'm between. Solve the inequality, then graph. I'm confident that you guys can do that. And looking at these word problems and turning them into inequalities, you should be able to do that as well. And you can check your answers and resolve any questions that way. Again, if not, you can just note it on your paper, and when you return, we can go over it. Or you can email me.